All right, in this video, we're going to look at questions 4, 5, and 6 on the worksheet. And so question 4 asks us to compute the vector and the scalar projection of u onto v using the figure to the right, which I've just copied up above here. So we're going to project the blue vector u onto the red vector v, okay, and noticing that this angle between the vectors is obtuse, right? It's more than 90 degrees. The projection vector will actually have the direction opposite that of v. The idea is, right, to look at the shadow of the blue vector onto the line spanned by the red vector v, which in this case is just the x-axis. Okay, so the shadow of blue onto the x-axis is this vector here in green, and we call this the projection of u onto v. Okay, so now in components, notice that the vector u, this is minus 9i plus 9j, and the vector v is just 4i. Okay, so from this figure alone, right, what is this green vector? Well, it's just minus 9i. Why? Well, because it has a 0j component, right, because it points parallel to the x-axis, and it's pointing right to the left, so negative 9 there is the I component. So negative 9i is the vector itself, and then what we call the scalar projection, right? I called this the signed magnitude of the projection vector. Well, the length of the green arrow is 9, but since the green vector has the opposite direction to the vector we're projecting onto, which is v here, that means the scalar projection will actually be a negative in this case. So negative 9 is the scalar projection. Okay, well, let's check these results that we're getting just straight from the figure with the expressions we defined in the last video for the scalar and vector projections. Okay, so for the scalar projection of u onto v, that's where we take the dot product of u and v and then divide by the magnitude of the vector we're projecting onto. So that's, in this case, the magnitude of the vector v. So u dot v, well, multiply the I components and the j components, and then sum the products, and you get negative 36. Okay, magnitude of v, well, that's just 4, and negative 36 over 4, yes, in fact, is negative 9. All right, so that agrees. For the vector projection, okay, this is where we're taking this scalar multiple of the vector v. So u dot v, this is negative 36. The magnitude of v squared, well, that's 4 squared, which is 16, right? And this multiple here, so negative 36 sixteenths, right, that's multiplying the vector v, which is 4i, and notice this simplifies to negative 9i, so it agrees. All right, great. So now let's turn to question 5. This is just a straight computation. It says compute the vector and scalar projections for the vectors u, which has components 1, 6, 2, and then v, which has components 10, negative 2, 1. Okay, so for the scalar projection, take the dot product of the vectors, which turns out to be 0, divide by the magnitude of the vector you're projecting onto, which in this case would be the magnitude of the vector v, which is root 105. But since the numerator there is 0, right, we find that the scalar projection there is 0. And then likewise for the vector projection, well, since that dot product is 0, this is just 0 times the vector v, which is, notice, the 0 vector. Okay, so the scalar projection is a scalar, so that's just the number 0. This is the vector projection, so we get the 0 vector. All right, so now looking at the picture, since the dot product is 0, we know, right, the vectors are orthogonal. And so if I project u onto the vector v in this instance, I just get a dot, right? And so if we're thinking about u as a force vector, right, what's the contribution of this force in the direction of v? And here we're saying, well, there is no force being contributed in the direction of v, and so that projection vector is just the 0 vector. All right, cool. And now for question 6, it says use vectors to find the smallest distance between the line L, described by the equation y equals 4x, and the point P with coordinates negative 2, 3. All right, so let's set that up over here. So drawing a picture of our line, and here's our point P, and we want to find the smallest distance between the blue line and this red point. And we're going to do that using vectors. So I'm going to go ahead and consider these two vectors, u and v. So the vector u in yellow has its tail at the origin and its tip at the point P. So in components, it's -2, 3. And then I'm going to look at this vector v, where I'm just choosing two nice points on the blue line. So its tail is at the origin and its tip is at the point 1, 4. So in components, v is 1, 4. Right, now what I'm going to do is project yellow onto green, right? Project u onto v. So when we do that, I can see that the smallest distance from the point P to the blue line, right, is the length here you see in pink, right, which I've copied that triangle over here to the left. It's this distance d right here that we're looking for. That's going to be the smallest distance from P to that line. So how can we go about finding that distance? Well, we can actually use the Pythagorean theorem for this. Okay, so let's find the lengths of the sides of this triangle. Well, the base here, that's just the projection vector of u on to v, right? And so what's the magnitude of this red vector here? Well, the sine magnitude is what we call the scalar projection of u on to v. And since in this case, right, our projection vector points in the direction of v, the scalar projection in fact is the magnitude of the projection, right? The sign there will come out to be a positive. So take u dot v and divide by the magnitude of v, and so that's going to give us a 10, just dotting those two vectors, and then divide by the magnitude of v, that happens to be the root of 17, okay? 1 squared plus 4 squared. Okay, what about the hypotenuse? Well, that's the magnitude of u, and that's the root of 13. And so the side we're missing, right, which is the length we're ultimately interested in, can be found using the Pythagorean theorem. So I'm going to take the root of the square of the hypotenuse minus the square of this side here. And so that simplifies to 11 over the square root of 17. All right, great. Well, that does it for these questions. I'll see you in the next video.